Yes. See, we will start today oscillations. Okay? Oscillations. Oscillations is a part of waves and oscillations branch of physics. Okay, waves and oscillations. Now, there is a difference between how many types of motions are there actually? How many types of motion?
There are four.
Yeah, yeah, very good. There are
Four
four
types.
types of motion. Yeah, types of motion. Types of motion. They are the first one is linear motion. Second one is circular motion. Third one is rotatory motion.
Fourth one is oscillatory motion.
Fourth one is oscillatory motion. So linear motion means when a body is moving in a straight line, this is linear motion. Circular motion means if a body is moving about a fixed point. Okay. Then that is said to be circular motion. Rotatory motion means
Fixed axis.
about the fixed axis. This is what? This is
To and fro motion.
Okay. To and fro motion of a body. To and fro motion of a body is known as oscillatory motion. Okay. Oscillatory motion. To and fro motion of a body is known as oscillatory motion. Okay. Now, now there is a difference between oscillatory and vibratory. Okay. What is a vibratory motion? Is it the same or is it a small difference?
Small difference is there.
Difference.
Yeah. Oscillatory generally, if the oscillations to and fro motion is like less than 10 or near about 10, very slow vibrations or very few oscillations in a second, then that is said to be oscillatory motion. If it is more than 10, then we name it as vibratory motion. Okay, but the meaning is same. Vibratory motion. If it is above 10, we say it as vibratory. Now, so we have periodic and periodic motion. What is periodic motion? Periodic motion.
They're occurring at a particular interval.
Regular intervals of time. The motion in which the body or the particle that is reaches the same point. Same point after regular intervals of time. After regular intervals of time. After regular intervals of time. Then that is known as periodic motion. So, what is now? Can you give me an example of periodic motion? Example of periodic motion. The example is motion of moon around the earth. Okay. Or motion of earth around the sun. These are all periodic motions. Because see, our earth completes one rotation in 24 hours, and whereas the moon also the same. Moon, how many? It will take how many hours it completes? It's in 27 days.
20.
Yeah, 27.5 days or around 28 days. Okay. So the same, that is known as a periodic motion. Okay. But again, the moon again takes 24 hours to complete one rotation approximately. Now, so next here we have some few definitions. What is that? Frequency. Frequency, in some books it is F, in some books it is N. In our CBSE they write nu. Okay. So what is frequency? Number of vibrations made in 1 second. Number of vibrations made in 1 second is known as frequency. Units of frequency is what? Hertz. Okay, or CPS. Hertz is SI unit and CPS is CGS unit. CPS means what? CPS means CPS means cycles per second. Is that clear? CPS means cycles per second. Is it clear?
Cycles per second. Yeah.
Yeah, that's frequency. Now, it is denoted, that is, yeah. Next is time period. What is time period? Capital D. Time taken to complete.
One
Time taken
oscillation.
to complete one oscillation. Time taken to complete one oscillation is known as time period. What are the units of time period? It is measured in seconds or milliseconds, okay, or microseconds. Is that clear? Or nanoseconds. These are all time period, time taken to complete one oscillation, 1, 2, and 4 motion. Okay. How do you say that? Suppose if this is a pendulum, a simple example I'm taking. Pendulum. You know pendulum, right? Simple
Yes, sir.
pendulum. So suppose this is a simple pendulum. Now here, suppose this is A, B, and C. The body goes from here, returns like this, again comes back. Okay. This is one oscillation. Or we can go from one end and to the second. Okay, this is one oscillation. This is time period, time taken to complete one oscillation. That is time period. Okay. Or we can also, the one more unit for this is what? Per second. Why? The relation between frequency and time period is what? I think you studied in chemistry also this one. Relation between frequency and time period, nu is equal to 1 by d. Okay? Nu is equal to 1 by d. This is nu. This letter is nu, N-U. This is mu. Okay? Mu, nu. So that's the difference. Now we are going for the displacement of the particle. Displacement of the particle, then we will discuss about simple harmonic motion also. Now, like as you know, in you know, in our linear motion, we studied. Any doubt here up to until here? Any doubt?
No, sir. No, sir.
Okay. In linear motion, we have three concepts. What is that concept? The first concept is displacement. Displacement. Second is velocity. And third one is acceleration. Is it not? The same way in oscillatory motion also we have equation of displacement, equation of velocity, and equation of acceleration. Okay, equation of acceleration. Now, so we have seen one motion where this is oscillatory motion. Simple pendulum is also a best example of oscillatory motion. One more example we will see now. Now, one more example. In second example, like there is a spring mass system. There is spring mass system. Okay, this is spring and this mass connected to the spring mass system. Spring mass system. So what happens here? This is a to and fro motion. This is to and fro motion. Okay, spring mass system. Now what happens here? M is the mass of the body and having certain spring constant. Now, whether it is any type of motion. So see, we will go back to trigonometry or some concept. Okay, trigonometrical concept. Like suppose you know what is this type of wave. What is this wave? Any idea? Okay, mathematics people. This is sine wave, sine x. Y is equal to sine x graph. This is cos x graph. Starts from 0. This is plus 1. This is minus 1. Again, this is 0, plus 1, and minus 1. This is cosine graph. This is sine graph. Sine starts from 0. This is 90. Okay. This is 180. This is 270. And this is 360. 2 pi. Same way, this is 0. This is pi by 2. This is 90. Sorry, 180. 2 pi by 3. 270. And this is 360. Okay. So it starts from 0. You know the values, right? Sine x graph and cos x values. So based on those values, ratio values, sine x and cos x values, this graph is plotted. So this is sine x graph. This is cos x graph. Why do we do this one? Example, like suppose I am taking a spring mass system again. Okay, I am taking a spring mass system here. See, suppose this is a spring. This is the mean position, and we stretch this one. When we stretch this one, what happens? It goes like this, and again it will return back. When it returns, it will become like this. Okay, so what happens here? This is mean position, and these two are extreme positions. Is it clear? This is mean position, and this is extreme position. Is that clear? Extreme position. So what happened here? How many mean positions? One mean position and
Two extreme positions.
two extreme positions. So it started from zero. Example, this sine graph started from zero, goes to the extreme maximum. This is the maximum. Okay, it is here now. Is that clear? Extreme. Then it comes back to the mean position. Then it comes back to a mean position. Then it goes to the extreme position. Then it goes to the other extreme position. Then it comes back to the mean position. Then it comes back to the mean position. So this is how the sine graph is resembling the motion of this one, motion of the spring mass system. Is it clear? Is it clear?
Yes, sir. Yes.
Once again, see here. The body starts from the mean position, is 0, goes to the extreme position, 1, comes back to the mean position, 0, goes to the other extreme, -1, returns to the mean position, 0. Is it clear?
Yes.
Is it clear? So this is how the motion of a spring mass system. Okay. So that is why we write y is equal to a sine omega t, or we write y is equal to a cos omega t. If it is following this path, sine. If it is following the other path, cos. What is amplitude? What is amplitude? Amplitude is maximum displacement of the particle, maximum displacement of the particle from its mean position. Maximum displacement of the particle from its mean position. This is the maximum displacement. Is it not? Maximum displacement of the particle from its mean position is known as amplitude. So what is the unit of amplitude? Amplitude is measured in meters or centimeters. Is that clear? Meters or centimeters. Is it clear, all of you? So these two are said to be what? Equation of displacement. These two are said to be equation of displacement. Understood? Now next
Yes,
is
sir.
what? Next is simple harmonic motion. SHM. So next is simple harmonic motion. Next is simple harmonic motion. So in simple harmonic motion, we will first write the definition. It is not a periodic motion. First of all, SHM is not a periodic motion. So, but the displacement is a sinusoidal function of time, sine function of. So, where we say here, force and displacement both are proportional to each other. Force and displacement both are proportional to each other. See here, you have seen here, the force and the displacement both are in opposite direction. So, F and X. So, here F is proportional to X. X is the displacement, or we can write Y is also a displacement. Okay, is it clear, all of you?
Yes.
Is it clear? See, simple harmonic motion, it is not a periodic motion. First of all, it is not a periodic motion. It is not a periodic motion, but displacement is a sinusoidal sine function of time. But displacement is sine function of sine or cos, sine function or cos function of time. That is said to be simple harmonic motion. Now, now before going to that, we will discuss about angular speed and angular frequency and angular velocity and phase concepts. We will discuss that before that. Okay, and representation of a wave on a circle. Okay, representation of wave on a circle. Circle. This is also known as phasor diagram. Very, very important for grade 12. This is also known as phasor diagram. Now what you see here, this is a, so suppose this is a sine wave. Okay, I am taking only one wave. Now this is a circle, man. This is O, A, B, C, and D. When it is at O, it is here, somewhere here. O. This is also center. Okay. Now when it goes to A, it will be somewhere here. A is here. See, when it is moving on when the particle is moving like this, the motion is moving like this. Is that clear? When the wave is moving on this is the wave. Particles are moving up and down. So it is the motion is moving like this. When it comes to this point, it is coming to this point. Okay, it's coming to this point. This is B. Now when it comes to C, see it is coming this way. So it will go this way. This is C. When it comes to this one, it is again D. Is it clear? Is this clear? See once again, when the point is at O, it is here. When the point is at A, it is here. When the point is at B, when the particle is at B, it is here. When the particle is at C, it is here. When the particle is at D, it is here. Is it clear?
Yes, sir.
Yeah. So this is representation. We are representing a wave on a circle. Suppose when I say somewhere here angle, this is said to be phi. Angle phi. This says phi. Is it clear? So maybe somewhere here. Is it clear? Somewhere here. The angle is phi. So representation of a wave on a circle is known as a phasor diagram. Clear? So now we'll discuss about the phase, then phase difference, all these concepts we'll discuss now. Okay. So, so we can write a y is equal to a sin omega t or y is equal to a cos. But if you don't want like this, you can write here x is equal to x of t because it's a function of time. So a sin omega t and x also we can write x of t is equal to a cos omega t. What is the difference of between writing x like this and y like this? What is the difference? What is the difference of writing between x and y like this? Anyone? This is along which axis? This is along x-axis and this is along
Y-axis.
y-axis. Very good. If it is along x-axis, use this for way of writing. If it is along y-axis, use the other way. Understood now?
So, but both are written in the same way, right?
Both are same. Both are same. But if the motion is along x-axis, we use this formula. See
Yeah, okay,
equation.
like that.
And if it is along y-axis, the motion is along vertical. Then we use this formula y. Is the same. Meaning is same. Okay. Now I'm going with the phase, then phase difference and all. Okay, that concept now. Now, what is a phase? Very, very important. If you can understand this concept, grade 12, current, electricity, electromagnetic waves, all this will be easy for you. Otherwise, it will go above the head. What is a phase? What is phase? Yes, anyone? Okay, phase is the angle made.
There is a type of variable.
Yeah, it's like an angle. Okay. The angle made with its initial point, initial position. Angle made with its initial position. That is said to be phase. See, suppose this we say phase. The angle made with its initial position. O, A, and B. Okay. Angle made with its initial position is said to be phase. But precisely, if you want a definition, scientific definition, which is not in your book, it says that it describes fact definition. It describes the position and direction of the particle. Position and direction of the particle. It describes the position and direction of the particle. Okay, the angle made with its initial position is said to be phase, or it describes the position and direction of the particle. Okay, that's said to be phase. Phase is measured in what? The unit of phase is measured in degrees or radians. Mostly it is measured in radians. Angles are measured in radians. Don't use degrees. Even though if it is convert degrees, you have to convert into radians. So suppose if it is 120 degrees, how to convert into radians? How will you convert pi by 180 into 120? So how much it will be? It will be 2 pi by 3. This is in radians. Is it clear? If it is pi by 4, convert into degrees. So pi by 4 into 180 by pi. Multiply like this, it will be 45. So this is the way of converting degrees to radians and radians to degrees. Keep this in the mind. Now we will go with one more case. Is it clear? First of all, phase. The angle made with this initial position. This is the initial position. It started from here. This is said to be phase. Now, or it describes the position and direction of the particle. Next is we have in phase, out of phase, and constant phase difference. We'll start with in phase. In phase. In phase, see carefully. Now, suppose this is one wave, and the second wave is also the same. It can be the same, overlapping the other, or it can be like this. See here. Yeah, see, this is A, B, C, D, and F. D, okay? Is it clear? Means they are in phase. Example, you are watching a movie, man. Simple example. So the phase angle is how much? Phase difference is? Phase difference between the two waves. Phase difference is how much? Phase difference is 0 degrees or 0 radians. Is it clear? Means example, you are watching a movie, man, and you're understanding the movie at the same time. What is the meaning of that? That is, you are in phase, or you're talking to your friend on the phone. He understands what you're talking at the same time. That means you are in phase, right? Is it clear? Is it clear? Suppose you have made a plan. You have made a plan for the whole day, and everything goes as per the time. That means what? That means, yes, one is replying.
It's a phase.
You are in phase. You are in phase with the time. You are in phase. Is it clear? You have planned for the day. Like 8 o'clock, you are going to do this. 9 o'clock, you are going to do this. 10, 11, 12, you have fixed the whole day plan. And you stick to the time properly, perfectly. That means what? You are in phase. Is it clear? The phase difference between both the waves is how much? It is, suppose the two waves are there. This is y1 and y2. Example, there are two waves like this. One is, this is y1 and this is y2. They are like this. They are y1 and y2. Is it clear? The phase difference is how much? 0 degrees. So next is what? Out of phase. Out of phase means how much? Out of phase. Out of phase means like suppose this is one wave and this is the second wave. See carefully. Phase angle between both the waves is how much? This is phi. Phase angle is how much? Here phase angle phi is equal to 180 degrees or pi radians. 180 degrees of pi radians. Is that clear? Out of phase. Angle between both the waves is 180 degrees. Then that is said to be out of phase. Like suppose you have planned. Example, one of our friend, he planned to go to, he want to go with his friend outside, maybe to for the party or something like this. And immediately you came to your home and you told, you told your mother or your father or your at your elders at your or parents at your home. They said they directly rejected. They said no need to go here and there. Sit at home and study. what happens? Your mood is off, right? Yeah, is it
Or
not?
out of
Yes.
phase.
Out of phase, yeah. Suddenly, what happened? When someone has made you sad, you are in a very happy mood, and suddenly, you know, uh, your mood from the happiness to sadness, that is said to be out of phase. Okay. Next is what? Constant phase difference. Very, very important part for optics also. Optics, wave optics. You will definitely remember this. This when the teacher is teaching you, constant phase difference definitely will come across this one. Very, very important concept. Constant phase difference. Now what happens? So there are two waves like this. Okay. Now what happened here? You can see here. See here. This is y1 and this is y2. Okay. So how will you define this one? Constant phase difference. Constant phase difference. Leading or lagging of a wave. Leading or lagging of a wave. Leading or lagging of a wave is known as what? Is known as leading or lagging of a
Constant
wave is
phase.
known as
Constant phase
constant
difference.
phase difference. Means maybe the angle between both of them is maybe 30 degrees or maybe 45 degrees or maybe 60 degrees. Some angle, some phase difference is there. Like suppose sometimes you're talking to India, maybe on board team or something like that. What happens? Sometimes the receiver is receiving after 1 second or 2 seconds. Yeah, I'm able to hear you now. Is it not? Sometimes it happens, right? There's a delay, maybe
Yes.
a fraction of second or maybe 1 second like that. That is said to be leading or lagging of a wave. Leading or that is said to be constant phase difference. There is some difference, constant phase. In that case, what we do, we disconnect the call again and we try again. Is it not? So sometimes it happens like that. So that is said to be constant phase difference. So do you want to be in phase or out of phase or constant phase difference with time? Yes,
Yes.
Constant phase difference.
you
Time.
want to have constant phase difference. Yes, anyone else? You want to be in phase or out of phase? You should be in phase. You should
In
plan
phase.
once. Yeah, plan once and stick to the time. That is in phase. Okay. So leading and lagging of a way. Or sometimes, one more example I will give you. Say, suppose you and your friend is walking on the beach side. Both are putting the right leg. Have you seen the march past in the Republic Day parade?
Yeah. Yeah.
Yeah. Have you seen that?
Yes, sir.
Yeah. What do you say that? Is it in phase, out of phase, or constant phase difference?
In
It's in
phase.
phase, yeah.
In phase. Why? Why in phase? What happens? All the right legs
They're all
together and
synced.
all the left hand backward. Right? The perfect phase.
Because there is no
All of them are
difference.
in the whole contingent is in the same phase. Right? So that is in phase. They are all in phase. Right? The best example is mark past. Okay. Now, so here we will discuss about angular frequency and angular velocity before going ahead. You know what is angular displacement? You have studied angular displacement, angular velocity, and angular acceleration somewhere. Where did you study that?
I think
Angular
system of
displacement,
particles.
angular velocity, and all. Where did you study that?
System of
System
particles.
of particles.
System of particles. Very good. Perfect. So we will do that now. Okay. Any doubt? Any doubt?
No, sir.
Okay, chalo. We'll go ahead now. So we are done with phase, in phase, out of phase, and constant phase difference. Okay. Now, now we will go with angular frequency, angular velocity. So, so there we have studied angular displacement. Now here I'll just give a quick recap of angular velocity and angular frequency. Angular velocity is denoted by omega, as well as angular frequency is also denoted by omega. What is this? This is rate of rate of change of
Velocity.
angular displacement. Rate of change of angular displacement is said to be angular velocity measured in unit of this is radians, right? Radians per second. So this is what angular frequency, number of rotations made in 1 second. Made in 1 second. Unit is what again? Radians per second. The formula for the first one is what? We write omega equal to delta theta by delta t. The second one we write omega equal to 2 pi by t. Is that clear? Omega equal to delta theta by delta t. And the second one is what? The omega equal to 2 pi by t. Omega equal to what? 2 pi by t. 2 pi by t. Now, why do we say like that? Suppose this is rotation like this. Suppose if it is like this. Suppose this is delta. This is what? 0. This is A and this is B. Okay. And this is C. Example. This is C. This is theta 1. And this one is theta 2. So how do we write now? This is time taken is T1. The whole time taken is T2. So now we write omega equal to theta 2 minus theta 1 by T2 minus T1, which is also written as delta theta by delta T, measured in radians per second. This is angular velocity. But angular frequency we write 2 pi by T. Why 2 pi by T? If suppose to complete one rotation he completed. Instead of small angle, he completed one rotation. The one rotation is capital T. And as per time period definition, time taken to complete one oscillation or one rotation. Time taken to complete one rotation or one oscillation is said to be time period. That is 2 pi by T. Is it clear? That is also measured in radians per second. Is that clear? Is it clear?
Yes.
So
Yes.
now in this lesson and the next lesson, we will be using angular frequency instead of using angular velocity. Is it clear? Instead of using angular velocity, we will be using angular frequency here for completing. Like suppose this is a wave. Now we are representing a wave on a circle, right? So what is happening when it is representing? When you are moving from here to here, it completes one rotation like this. The second time again one more wave. Second time it completes one rotation. So this is how we are representing the phase diagram. So we are saying time number of rotations made in 1 second is